Everyone, I am Mohan, Assistant Professor, Department of Mechanical Engineering, and in this video, we are going to have an introduction about heat and mass transfer. So, the objective of today's video or lesson is to understand the mechanisms of heat transfer under steady and transient conditions. And these are all the outcomes of the lesson. At the end of this video, you will be able to understand or define what is heat transfer and understand the difference between thermodynamics and heat transfer and understand the different mechanisms of heat transfer. So these are all the outcomes. Okay. Fine. So what does this picture tells you? A cup of hot coffee. So we all know from our experience that a hot cup of coffee left in a room eventually cools off to the room temperature. This is something that we experience in our day-to-day life. So whenever we offer a hot cup of coffee, when it is too hot to drink, what people normally do? So we will keep the coffee aside and wait for the coffee to cool down. So this is the human nature, because we cannot have a hard coffee, right? So we can have a coffee with the medium heat, right, or mild heat we can have. Too hot, no, will harm our tongue. Right? This is human nature. This is scenario one. And how is it related to heat transfer? That is the question. Why are you showing this picture? So how this is related to heat transfer? That I will tell you. And this is scenario 2. So what is this? This is soft drinks or cold canned drinks. So a soft drinks or cold canned drinks left in the same environment warms up. Right? It is opposite to a hot coffee. Hot coffee cools down, whereas the soft drink or cold canned drinks warms up. It is always served cool when we take from the refrigerator, right? But after a few minutes, it is slowly getting warms up. So, how does it happen? What is happening behind? So this is question that we must answer. Fine. First, so this is scenario 2. Let's come back to the scenario 1. Okay, how that coffee cools down, right? What is happening? See, this is the hot cup of hot coffee at a temperature of 70 degrees Celsius, and let us assume the room temperature is 20 degrees Celsius. Let us assume this is the winter season. In the summer season, the temperature around 30 degrees Celsius. Oh, this is the summer season. So the environment temperature is 20 degrees Celsius. Yeah. Hot coffee temperature is 70 degrees Celsius. So here there is a temperature difference, 70-20. So what will happen? The energy transfer. So how this coffee cools down? Because of the energy transfer from the hot coffee to the environment. Okay, the transfer of energy from the warm medium to the cold medium, or the transfer of heat from the hot body to the cold body. Right? So this is how the energy transfer takes place. I hope you understand how this coffee cooled. Okay. So heat flows in the direction of decreasing temperature. Because heat always flows from higher temperature to the lower temperature. Right? So case 2. In the scenario 2, a cold canned drink or soft drinks. Let us assume the temperature is 4 degrees Celsius and the outside temperature is 25 degrees Celsius. Outside temperature or ambient temperature or room temperature, whatever it may be. Okay, it is 25 degrees Celsius and this 4 degrees Celsius. So here the heat is transferred from the room or the ambient to the cold canned drink or the soft drinks. So this is why the cold canned drink or the soft drink is getting warmed up when it is left in the room. Okay, when it is both the coffee and the soft drink in the same environment, but one is getting colder and another one is getting warmer, right? So this is something that we experience in our day-to-day life, right? Every day we experience this scenario, but we might not understand, right, why this is happening. So this is another practical example. A hot egg cools down, right, after a few minutes. So when we have the boiled egg, okay, when we eat a boiled egg, a very hot boiled egg, we cannot have it, right, immediately. So what we do is we left it in a room, or we will immerse the hot egg into the water, right? So when we immerse the hot egg into the water, and the egg will cool down. Okay, there's a two-way that we can cool the hot egg. Right? So this is another example. So everywhere the heat transfer takes place. Right? The heat transfer plays an important role. Right? Fine. Now let us understand what is heat transfer. Right? I think at this point of time you might have understood what is heat transfer. So although I will tell you the formal definition of what is heat transfer. Heat transfer is nothing but the flow of heat or thermal energy due to temperature differences. Right? The transfer of energy from warm medium to the cold medium, or the transfer of heat from hot body to the cold body because of temperature difference. So temperature difference is the driving force for heat transfer. Right? So how fluid flows because of the pressure difference. Whenever there is a pressure difference, there will be fluid flow. Similarly, whenever there is a temperature difference, there will be a heat flow. Right? So the science that deals with the determination of the rates of energy transfer is the heat transfer. So the subject heat transfer is deals with the determination of the rates of energy transfer. Right? So I hope you understood what is heat transfer by this time. Right? So before moving on to the different modes of heat transfer, we must understand the difference between temperature and heat. I hope many of you will have confusion about the difference between the temperature and heat. What is that same? Is that both entity are same or different? We have some confusions, right? I will clarify in this slide. So temperature is nothing but a measure of hotness or coldness of an object, right? So it is a measure of the amount of energy possessed by the molecules of a substance, right? Measure of the amount of energy. Right? I will underline the word. Let me use the pen to highlight this. Is a measure of the amount of energy possessed by the molecules. Okay, or we can say the measure of hotness or coldness of an object. Whereas heat is a form of energy. Okay, it is an energy. So heat is an energy. Very important. No, heat is an energy in transit. Okay, spontaneously heat flows from a hotter body to a colder one. Right? Like we seen in the previous slides, a hot coffee cool down and a cold canned drink warms up, right? Because of the temperature difference. That's what it says. So temperature is a measure of hotness or coldness, whereas heat is a form of energy. Right? Fine. Let's move on to the next slide. Okay. Now, what is the difference between thermodynamics and heat transfer? Right? So, you may be wondering why we need to take a detailed study on heat transfer. After all, the amount of heat transfer can be determined, as the system changes from one equilibrium state to another equilibrium state by thermodynamic process alone. Right? But thermodynamics does not give any indication about the rate of heat transfer or how long that takes place, right? So by using thermodynamics, we can determine the amount of heat transfer, but not rate of heat transfer. Okay. So in practice, we are concerned more about the rate of heat transfer than with the amount of heat transfer. Okay. Let me give you a practical example. Right. So what is this? So this is a thermos bottle. Okay. Thermos bottle or flask, thermo flask. So, and I think you all know the purpose of flask. So it is used to retain the hardness for a longer period of time, right? So we can determine the amount of heat transferred from this, thermos bottle, where inside we have a coffee, right? We can determine the amount of heat transfer from the thermos bottle as the hot coffee inside cools from, let us take 90 degree Celsius to 80 degree Celsius. Okay, 90 degree Celsius to 80 degree Celsius by thermodynamic alone we can determine, okay, amount of heat transfer. But a typical user or designer is primarily interested in how long the coffee will be before cools to 80 degrees Celsius. That is the question. Okay, let me give you a very simple example. Let us assume we are standing in a queue. We are standing in a long queue. Okay, the first question that arises in our mind is how long this queue will take place. How long? How long I have to wait? How long this queue will take? That is the very human nature. Everyone will ask this question: how long this take? So we are more interested in how long. Okay, so this is something cannot be answered by thermodynamic process. Okay, it only deals with the amount of heat transfer. Okay, not with the rate of heat transfer. So that rate of heat transfer can be understood and studied with the help of heat transfer. Okay, so that is the primary difference between thermodynamics and heat transfer. Let me put it in the simple words. Thermodynamics talks about the amount of heat transfer, whereas heat transfer talks about the rate of heat transfer. Okay, so amount of heat transfer means, so Q. So this is, we all know, we must have studied in thermodynamics. Q is the symbol of heat transfer, and amount means the unit is kilojoules, whereas rate means kilojoules per second or watts. Okay, kilojoules per second or kilowatts, right? If you use kilojoules means kilowatts, or joules per second means just watts. Okay, so we are normally interested in how long it takes for the hot coffee in a thermos to cool to a certain temperature, which cannot be determined by thermodynamic analysis alone. Okay, that is why we have to take a detailed study on heat transfer. Fine. So now moving on to the application of heat transfer. Okay. Fine. Before that, let me summarize the point that I have discussed in the previous slide. Thermodynamics tells us how much heat is transferred. Okay. So how much heat is transferred. Fine. How much heat is transferred, how much work is done, final state of the system. Whereas heat transfer tells us how, how means in what mode, that we are about to see the different modes, with what modes of heat is transferred and at what rate, yes, at what rate, joules per second, and temperature distribution in the body. This is additional point that is heat transfer, temperature distribution inside the body. Fine. So these are all the summary. Now I got to just the important points of heat transfer. Right. Fine. Now moving on to the application part of the heat transfer. So where not is applied heat transfer everywhere. Even in our human body. The first is our human body. We are sitting. We are constantly exchanging heat and dissipating heat with the environment, and that depends on the activity that we do, right? So activity means as someone who is doing jogging, or who is working out in gym, he will dissipate more heat, right? And if someone sitting ideally, that dissipation level will be different. Someone talking, for example, I am talking to you, right? I will also dissipate heat, right? So our body or inside continuous heat exchange mechanisms inside. We are eating that that food has to be digested, and the heat mechanism, the mechanism is always there in our body. Right? So human body, and one more point is that during summer season we have different seasons like summer season, spring season, and winter season. Based on the season, we would like to wear clothes. For instance, during summer season, the outside and ambient temperature is high, right? We would not like to go outside. We would keep ourselves inside the room, and we'll be very happy if we have air conditioning system, right? So during summer season, we would like to wear some thin clothes, right? Because outside the ambient temperature is high, there will be more heat transfer from outside to our body, okay? Because of high temperature difference, right? Hotter environment, because of the hotter environment. Whereas during winter season, we would like to wear some jerkins or sweaters, something like that, so that we can avoid heat dissipation from our body, because our body loses more heat during winter season. Right? That is why we wear, we cover our body entirely, especially those who are living in cold climates, like Ooty and some other foreign countries, cold countries. They cover their body entirely to avoid the heat dissipation. Right? More heat loss means more discomfort. So that comfortness is very important for human, right? So we all, we all like to be, in the comfort level. So where the heat transfer plays an important role. Then air conditioning system, as I said, air conditioning system, it is invented for the comfort of the human beings. Okay. So we cannot control the entire ambient or environment. So we don't have any superpower to control the ambient temperature, but we can control the temperature inside the room. Right? Inside the room we can control. That is the air conditioning system. And circuit boards, car radiators, power plants, and refrigeration system. These are all some applications, some important applications of heat transfer. Okay, so without understanding heat transfer, the basics of heat transfer, different modes of heat transfer, we cannot do anything about it. Right? To design a radiator, we must understand, what is heat transfer, what is convection, and all. So there are so many things are there, right? So for that, it is really important to learn about heat transfer. Fine. Next, the different modes of heat transfer. There are different modes. First one is conduction, right? Conduction, convection, and radiation. There are three modes of heat transfer. Let me tell you one by one what is conduction, what is convection, and what is radiation in the next slide. Fine. Okay. So I hope you will be able to see this. First, what is conduction? So what is happening? This is some part inside water is boiling, right? Here water is boiling, and here someone is heating the iron rod, using the candle, and here someone is getting warm up, right? Someone is getting warm up in the campfire, and this is sun. So, how is it related to this example, these practical examples that we see in our day-to-day life? Right? First, let me simply explain what is conduction. Okay, conduction is the transfer of energy from one molecule or one particle to the adjacent particle. Okay, due to the temperature difference. Or conduction is the transfer of energy from more energetic particles to the adjacent less energetic particles. Okay, let me explain with a simple example. Here, let us consider this is the iron rod. Okay. So this is the iron rod. Fine. It is iron rod, and this is candle or heat source. So when we heat the iron rod at one end, what will happen? So this portion or this side will be heated fast, right? And after a few minutes or after some time, we can sense or feel the warmness in this side also. We cannot hold simply, right? At the beginning, we can hold this iron rod, right? That too, it is very difficult. But let us assume we are holding the iron rod, right, and heating. But after some time, that we can sense that heat in this side also. So how? So what is happening? So how that happens? Because the particles or molecules present in this side, okay, it's getting hotter, or I can say, it becomes more energetic. Right? It becomes more energetic. So that more energetic particle transfers energy to the adjacent less energetic. Okay, less energetic particles. Okay, and then so on. So like this, it transfers the heat. So basically, this became more energetic. The next particle, the next particle, the next particle. Then finally, it reaches here. So this is conduction. Okay, the transfer of energy or heat from more energetic particle to the adjacent less energetic particle when there is a contact. Okay, this is conduction. And